Welcome to SolidCAM Professor on our series of Getting Started. I'm Sydney, your SolidCAM Professor, and in this part we'll be demonstrating the use of mill turn. Look at our part that we have on our screen. You'll see that there are both turning operations that must be done and also milling operations that have to be done, such as these holes over here, this surface over here, which is actually a 4-axis simultaneous operation, and also the holes in the back, on the side, the slots. In other words, we have a whole bunch of different types of operation that both calls for turning, for milling, and for turning. Now, just a quick word about mill turn. Mill turn is basically looked at as a milling machine that is also capable of doing turning operations, lathe operations. When we start our operation, if we only want to do milling, we do not even have to create a home position for turning. We can treat this as a complete milling machine with all the necessary information, such as a coordinate system, our regular stock, anything, and if we're not doing any turning, we do not have to define any of our material boundaries, as you see here. Now, obviously, though, in this part, we're using both milling and turning. So let's take a quick look at our coordinate system. And in this case, I've decided to have all my coordinate systems working off the center of the part itself in all directions. Now, light it up one at a time. And you can see each coordinate system as we go. We have our first one, which actually is down from the center. Our second one, and so on and so forth. In other words, every position that I want, I can have my home position as seen here. Now, in my first set of operations, I'll be first doing my turning operations. And I'll be using, obviously, Mach 1, position 1, as seen over here. Now, the first thing I'd like to do is to actually do a rough cut of the outside of this part. And if I go into my operation, first of all, even before I do that, you'll note when I'm working in mill turn, I can add a milling operation or turning. And each operation that I add has all the functions as a regular milling operation or a regular turning operation. So let's go now into my first operation. Now, the operation that I've created, you can see we're using a turning operation, and the profile that I'll be using will be the outside of the part itself, and you can see my extension on either side. Now, the tool that I will be using will be a regular external roughing tool. If I go into show, you can see the tool itself with all the information that's needed for that particular tool. In my technology area, I'll be doing work type of rough, as you can see in the picture over here. I'll be working along the part as opposed to the face. Be working external as opposed to internal. Take a look at the pictures, they're always changing, showing us exactly what we'll be doing. I will not be working with compensation. If I want, though, I could. And I can either use a machine cycle or not use the machine cycle. My rough copy, I'll be doing my rough steps every millimeter with the appropriate offset from the wall. And I will not be doing a finish cut in this operation. If I do save and calculate and simulate, you'll see that the tool is working just on the outside exactly the way I've created my geometry. Let me just go into my turning simulation. and I'll just move it over more to the middle. You see that it's basically going on the outside. And turning that area, leaving the excess material that I asked for it to leave. Now in my next operation, I'll be using the same profile with the same tool, but just doing a finish cut. So if I open my operation, you'll see, again, I'm using the same profile as seen here. You can also see what material is actually left over to be cut. I'll be using, like I said, the same tool. In my technology area, I'll be doing rough on the area that still has to be cut. But I will also be doing a finish cut on this part itself. And if you take a look at the simulation, and again, I'll be using my turning type of simulation. You can see, I'll do this one step at a time. The tool is going in, cutting only the area that has to be cut. And now the outside of this part has been completed. What I'd like to do right now is drill out the middle of this part here itself. And that's simply done by a simple drill operation. And again, you'll note that when I go into my geometry, there is no geometry to be chosen because when doing turning, you can only drill in the middle itself. My tool that I will be using will be 11mm tool with a typical 120-degree angle on the tip. My levels, my technology, pick start position, drill end position. I'll just take a quick look at the simulation. You'll note, again using the turning, and let me just enlarge this and put this in the middle. The drill goes all the way down through the part, and we're done. Now, in my last turning operation, what I'd like to do here now is simply turn out the middle of the part, the inside diameter, to its final diameter dimension. If I were to go into the operation, you'll see again we're using the turning operation. My profile in this particular case is as you see over here. The tool that I will be using will be an internal rough tool, as seen in the picture over here. In my technology area, again, we'll be using rough, and we will also be using a finish operation within this particular operation. If I were to simulate the part, and this time I'll use Solid Verify, you'll see that the tool goes in, and I'll put it in a mode where we can actually see the inside as we're turning. Goes up and finishes whatever has to be done on the inside of this part itself. Another thing I'd like to point out over here is in my technology area, we should note that we're working again long, but this time we're working internal as opposed to external. In my next operation, I'd like to start now with my milling operation. And the first thing I'd like to do is actually mill out this slot over here. Now, what you'll note is that this slot is actually on the same home position as my turning. And I can use both this home position for both turning and for milling. I do not need a separate home position for the two options. So let me just go into my operation that I've created. And you'll see, like I said, we're using a Mac 1 position 1. My profile is this area over here, that border over there. The tool that I will be using will be a 2.5 millimeter end mill. My levels taken from the part. And my technology, as you can see, this is a regular milling operation. All the functions that we have in normal milling, we have it here also. Working one way, constant, doing a finish cut only in this particular case, at a step down at 1.25 millimeters. Of course, we have our link in and lead out, both being used as a tangent of 4 millimeters. If I were to do a simulation, and this time I'll use the Solid Verify simulation, you'll note that the tool will come in just like a regular milling operation. Let me just let it run till the end. And it has milled out the entire slot, as you can see over here. In my next two operations, I'd like to do a drilling operation on these holes over here and a drilling operation on this hole over here. Again, as you can see, these are typical milling operations that have the drill functions exactly the way we have it in a normal milling. As you can see over here, I've picked these 3 drill points. Again, picking my tool, in this particular case a 2 millimeter drill. My levels exactly the same as a regular milling operation. And the same thing with this operation over here, this drill operation. There is no difference between this and a normal milling operation. And again, note, all these 3 milling operations were done in the same home position as my turning. Now, for my next set of operations, I'd like to do a pocket operation over here and a drilling operation over there. Let's just take a quick look at this operation. You'll see that my tool, that my geometry is the outside border of this part itself. In my levels, as you can see, now let's go into my technology. And true, I could have actually done this using a face mill operation. But I'd like to show you also that within the pocket operation, we can also, let's call it, work on the system. I'm doing it in a normal profile operation. But what I've done is I've given the wall offset in a negative field, thereby forcing the tool to go past the boundaries of the part itself. My link in, link out, I haven't touched that. Simple. Save and calculate. Oh, but before that, let me just go back into my technology area and go into my data. My data area, by the way, if I want, I can work from the inside or from the outside. Let's just do a quick save and calculate and simulate the operation. And as you can see, when I do my solid verify on my part, the tool is going down, milling the part. Now you'll note that even though I asked for it to do one side, it actually did both sides. That's because you'll note that next to the operation, we have a small little box over there that says 4 in it. In other words, I'm working on a 4-axis operation here, indexial operation. What I've actually done here is I've gone into what we call transform, and we have here 4 axes. And as you can see, what I've told it over here is to do my original operation and then add another operation turned at 180 degrees, thereby causing it to work on both sides, this side and on the other side. Now in my next operation, again, I'll be adding a simple drilling operation over here, as you can see. And in this particular case, let's take a quick look inside the operation itself. We have our drill points as seen over here. We have our tool, in this particular case a 2.15 millimeter tool. My upper level, the drill depth that I want to go to, technology, and again I can do my simulation, and you'll see that it drills out those 2 holes exactly where I asked it to drill out to. Put this into more solid mode. Again, the tool goes down and drills out those 2 holes. Now in my next milling operation, I'm just moving along, and I'll be cutting out this area. So for that I have my Mach 1 4th position, and again just a simple profile operation to mill out that area. As you can see within the operation itself, again my geometry, my tool, my levels, technology, everything that is needed to complete this part. In my next position, what I'd like to do now is work on this hole over here. So now again we have our drilling operation to drill out the hole, and I've used a pocket operation to do the spot on top. Again, all this very simply done within mill turn, just by simply picking your home position, just like any milling operation. Same thing with these holes over here. I have my home position and my pocket, the exact same thing as this one here. The only difference is different home position. Now in my next operation, I'd like to work on this area over here. I have that as Mach 1 position 2. And in this particular case, as you can see, I'll be doing a pocket operation, but I'll be actually turning the part while doing the pocket itself. Let's just take a quick look at what I've done over here. If I were to look at the operation itself, you can see my geometry is on the floor of the pocket itself. And you'll note obviously that the floor is not a straight floor, but it's actually wrapped around my x-axis. So we have now the option over here on the bottom called 4th axis. If I were to open it up, you see we're working on a wrap. Like I said, we wrapped around, and we're wrapped around the x-axis. Now the tool that I will be using is a 2.5 millimeter tool. My upper level, to do the upper level, all I do is simply click anywhere on the outer surface. And my pocket depth, all I do is click anywhere on the floor of that pocket itself. My technology is the same as any technology in any pocket that I have. Let me just do my simulation now. And I'll use the Solid Verify simulation. you'll see that the tool will go in. And I just turn it to the right position here. One step at a time is actually milling out the bottom of that pocket itself and moving, having the x-axis move around in order for it to complete this part. In other words, I'm doing a simple fourth axis operation, but the operation itself, again, let's take a quick look. All the information is exactly like any pocket operation. The only difference is over here I've used this option of fourth axis. If I were to simulate now my entire part using Solid Verify, you'll note I have my first operation, next operation, the hole in the middle, the sides, my milling. Now let it run now through the end. Everything that has to be done, all the sides, all the holes, the pocket, and now we've completed machining the entire part. Thank you for joining us on SolidCAM Professor. Take care and have a nice day.